Stream channels can be classified a little further than just their drainage pattern. We look at streams as either being braided or meandering. There are other classifications, but those are the two main classifications. A braided stream, like in the image here, the stream breaks up and goes around sandbars or gravel bars and then comes back together. These sand or gravel bars are not permanent. For sure, they can get vegetated, and over time they can get more vegetated, but the next flood would maybe knock that vegetation down and rework the little islands in the stream. A meandering stream, and I've used this term a little bit already, zigzags through the floodplain. Sinuous just means that the loopy curves, and these are going to form where the gradient is pretty low. And a braided stream, let's go back a second, these are going to be formed in places where there's a high sediment load. So maybe disturbed soils, maybe there's a volcanic eruption, maybe there's a mud flow, where glaciers have created lots of erosive material outwash from the glacial erosion. Yeah, places with lots of sediment are going to have braided streams. The mouths of rivers often have braided streams as well, like on a delta. The meander, there's going to be less sediment and maybe finer grain sediment. The gradient is pretty low, so there's not a lot of sediment moving through the system. The meanders are going to form over the floodplain. The thalweg, remember, is the main current of the stream where the velocity is the highest. It's going to bounce from side to side along the channel, and as it does that, it would create a cut bank where it's the fastest and a point bar where it is the slowest. Over time, those grow. This sinuosity gets more developed and more developed. The meanders get more developed. Over time, what can happen is if it gets way out there on the floodplain during a flood, the channel can cut right through that meander. And so in the next image here, it's cut off. And now the channel is anew and has left that meander kind of high and dry. And that's formed what's called an oxbow lake. Oxbow lakes can be really important to the ecosystem. A little bit. Oh, that's a manatee and a baby manatee if you're looking at those. The oxbow can be pretty important part of the ecology of a floodplain because it over time can silt up and form a wetland. Move my face out of the way here. Yeah. La 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 la. Here I go again. This is just showing the same thing again with sinuosity over time, and the point bars are going to grow. So each of these loops in here represents like a stage in the growth of that point bar. And the oxbow lake can be left out on the floodplain. Okay, anything else here? Not really. Here's a really squiggly meandering river with lots of little oxbows, these dark U-shaped, oxbow-shaped marks on the landscape, and you can see places where the point bars have grown over time. Somewhere like in here, probably, maybe the next flood event. Whoops. Over time, that could cut off and create more oxbows where it gets really tight. Ooh, especially here, right? That's like ripe for an oxbow lake there. All right, so the meandering river is going to only be using just this thin strip of the floodplain at any given time, except when there's a flood event, and then the river can take up the whole floodplain, right? That's why there aren't houses built right along the river. They're built over on the edges. Right beside the river, because of flooding events, levees can form, natural levees, where the water leaves the stream and is carrying sediment, leaves the channel carrying sediment and sediment is dropped right at the edge of the stream channel. It can grow up over time, and these parallel ridges are called levees.